Vaccines, the immune system, and immunization. 30 trillion. That's the number of cells that make up the human body. Beyond that, at least that many bacteria, fungi, viruses, and protozoa call each one of us home. Our immune system has the difficult task of distinguishing between our own cells and foreign cells, and between healthy and sick ones. The body has two different modes of defense. The innate immune response triggers immediately once a pathogen is detected in our body. It always operates in the same way and fends off about 95% of infections. By contrast, the adaptive immune response takes time to come into effect. It operates by developing defense mechanisms to fight off a specific pathogen. In the process, memory cells are created. They help to prevent a new outbreak, a second infection, or further transmission of the disease. A highly effective system. Nevertheless,
about 60 million people die each year, and about 1/4 of those people die of infection, even today, though it's much less apparent in what we call the developed world. Nonetheless, it's a huge problem everywhere, and specifically in places where there isn't ready access to antibiotics and where the likelihood of infection is greater.
In addition to nutrition and good hygiene, vaccines are a main factor in improving public health. Vaccines, also known as active immunization, use the adaptive immune response to arm the body against specific diseases. Samples of the pathogen, either dead or alive but in a weakened state, are injected into the patient. The body then reacts to the simulated infection with an actual immune response that produces memory cells, which in turn leads to immunity. If an infection is already in progress, or the patient's immunization history can't be determined due to injury or time pressure, there's also an option known as passive immunization. In it, antibodies are injected to help the body immediately fight the disease agents. Protection only lasts 6 to 8 weeks, however, because the body doesn't produce memory cells of its own. Emil von Behring used passive immunization to cure children with diphtheria. He was awarded the first Nobel Prize in Physiology or Medicine for this work.